Good morning, everyone. I hope I'm audible to you. Am I audible to you? And can you listen to me? Just type a quick yes, no. Great. So, as I said, we will continue with the exception handling. Some 2, 3 examples are there. You have to find the output, and then we'll start with thread. Then we'll start with the threading concepts. So, a program is given to you on the screen. Kindly take 2 or 3 minutes, figure out what it is going to give me. There is a try finally class which has got a try again method, which has got a try again function, which has got a try block and the final block. Kindly note there is no catch over there. The function is terminated with return a, and there is a public static void main which says new try finally dot try again. That means we are creating an anonymous object and making a call to the function try again. So what should be output if I run the code? A is 10, in the try block we make it 11. So in the final block, it becomes 12, and then that particular value is returned, and that will be printed out over here. Okay, good. The next example. There is a base class, there is a derived method. Sorry, there is a base class, there is a derived class. Both of them have got a function my method. Okay. In the first case, it is throwing exception in initialization error. In the second case, it is throwing runtime exception. You have been told to figure out, go through the exception hierarchy and tell me what it should give me. Will it give me base? Will it give me derived? Will it give me error? One, two, three. Yes. 3 students have written it correctly. Yes, it is a derived one because it's a function overriding. Base class reference and the derived class. So obviously my base class reference can be made to point to the derived class we learnt in inheritance, and then we have a function called as my method. Okay, so let me test you. What will happen if I comment this out? What will happen if I comment out the my method in the derived class? In case I comment this out, then what should be the answer? Will it be base? Will it be error? So what happens when we don't have a function over here is it won't come over here because this particular method is throwing the exception initialization error. Yes or no? So what will happen? You will get something called as a base over here. Something called as a base. Kindly pay attention. This function as well as this function are throwing some exception. This is throwing exception in initialization error. This is throwing runtime exception. That was the first case. In the second case, I told you do not write this. So when you don't write this, we are throwing the exception initialization error. So you will get a base. Now what you do is, that's the second example. Okay. Now what you do is you remove this. Okay. And you remove this. And tell me now what should happen if I run this particular program. So I have removed the throws over here, and in the derived class what I had done, I have removed the function, and then I am saying make a call to the obj dot my method over there, obj dot my method over here. It will give me base. It will give me base. Good. Little bit difficult. Go through this example very carefully and answer it after 2 minutes. Run this and check it. There is a class Java, eJava. There is a foo function. Okay. And I'm making a call to the foo function. In the try block, I'm saying string s is equal to null. Then we are displaying 1. So the try catch block is, see, there is a try, within that there is a nested try. Okay, in the nested try, I'm trying to display s dot length, but s is null. Okay, so I'm catching a null pointer exception in which it is displaying inner. Outside that particular try catch, what I have is system.out.println 2. That means, pay attention over here. This was an outer try. This inner try catch is ending over here. That means After this, we have SOP2. That means there is SOP1 over here, then the inner try catch, and then SOP2. And then I am catching a null pointer exception over here, and in which I am displaying the outer. So the question is, when I say string S is equal to null, okay, what it should try to catch? Will it catch this particular outer exception, or will it enter into this and check out the s dot length and throw this null pointer exception inner and then come over here and display the outer? Take your own time, analyze the flow. Okay, so this was a tricky example. Let me explain this. So I made a call to the foo function. So control comes over here. Here we have a try block. String s is equal to null doesn't give any error because we are simply initializing it with null. Print 1. Okay, so the first line output should be 1. Comes inside, it tries Any doubt you have? Am I audible to you and the screen is visible? I think there was a drop in the connection. Can you just type a yes? Okay, great. Good. So always remember, exception handling is not a standalone program. It is supposed to be part of the other code. For example, if you are doing the file handling, JDBC handling, or if you are running threads, or you are carrying out the array operation. So at that time, you are supposed to use a try-catch mechanism. Okay. So let's start with threads. Let's start with thread. This is going to be a little complicated example because till now you haven't seen a multi-threaded application. You haven't seen a multi-threaded application. Okay. So we have an operating system. Okay. In the operating system, what you have done, you have started an online session for the Java compiler. You have started a notepad for writing down the note. You have started MS Word. Okay. Now, all this program, online session in which you are running a Java program, notepad in which I'm displaying the document, or the MS Word in which I'm displaying the document, these are called the processes. Okay, these are called the processes. That means when you start this, a process will be associated with this application, MS Word, notepad, online session, something like that. Okay. Now, within that, assume that you're typing the document, or you are formatting the document, or you are taking the print of it, or after every 5 seconds, automatically it is taking the saving the document. Okay. All these are called the threads. All these operations are called the threads. There is only one process, and within that process we have the multiple threads. One thread is handling the typing, second thread may be handling the formatting, third might be handling the printing, the fourth one automatically MS Word is going to have a saving. Depending upon what time you have set, it is going to save the document. So normally what we have is a process, and within that process what we have is a threads. Now, what does Java tells us that you can create the different threads over here. Okay, you can create the threads. And as a software engineer, we should be comfortable in creating the various threads. Ultimately, it is a project leader and the team leader who is going to discuss which part of the code should be handled using the threads, depending upon that particular project scope and how the project is running in the memory. That call will be taken by the project leader or team leader. Clear? But your job will be to write a code or to write a threaded application. Is it clear to you? Is my screen visible to you now? What I said was an operating system will be starting the various threads. Okay, this for the operating system will be starting the various processes. So depending upon the multiple tabs, those will be handled using the separate processes. So that if one program collapses, it won't affect the other program. In a particular program, the different tasks are handled by something called as a threads. And Java allows us, that means the process can have the multiple threads. And now the Java will allow us to create the various threads. And as a software developer, we should be comfortable in creating the various threads. We should be in a position to create the various threads. So our job is to understand how we can create this particular thread. Is my screen visible to you, the notepad screen? Is my notepad screen visible to you? Okay. So the step one. What I'm going to do is, I have a class called as current demo thread. Okay. And in the current demo thread, I have got a main function. In the main function, what I'm going to do, I'm not going to create any multiple threads. I'm just going to catch the thread. So how do I catch the current running thread? I simply take a reference of it by saying thread t is equal to thread dot current thread. Thread t is equal to thread dot current thread. Available in java.language. Okay. So now I display the current thread by simply saying SOP T. SOP T. Okay. So when I run the code, it will be clear to you what should this T display. Okay. So first point is, the first two lines are capture the current instance of the main thread. As soon as I run the program, a thread will be started, and that thread I should display. The second step is, using this particular thread, what I'm going to do, I'm going to change the name of the thread. That means the thread which is running, I'm going to change the name of the thread. Okay, you change the name of the thread. Then what I'm going to do, I'm going to execute a loop. I'm going to execute a loop. And this particular loop is going to run from 5 to 0. But in that, what I'm saying, thread.sleep 1000 millisecond. 1000 millisecond. That means it will sleep for 1 second. Now remember that thread.sleep by default gives an interrupted exception. So compulsorily we'll have to write a code in try catch block where I'm going to catch the interrupted exception. Why? Because your thread, when a program is running, a thread may be interrupted by any other thread. So the signature of the thread.sleep is, it is always going to throw an interrupted exception, and hence your code should be put in a try catch block. Otherwise, I could have simply said for n is equal to 5, n greater than 0, n minus minus, opening bracket, system.out.println thread.sleep. There was no need of using this. There was no need of using this. But since this particular documentation says that this particular thread is going to throw the interrupted exception, if you look at the Java documentation, hence I have to write the code in the try catch. So my program is broken into three things. My first step is to catch or to display the current thread. That means as soon as the system has started, it should display it. My second step is to change the name of the thread. And my third step is to basically make a thread sleep for how many seconds? 1 second. That is 1000 millisecond. Three tasks I'm supposed to do. So let me copy this and let me share my screen with you again. Okay. So there is a class main in which, let me put these two lines together. So part one of the program is display the current thread as it is. Do not do anything, just display the current name of the thread. Okay. Step two is change the name of the thread. And step three is run the program, run the particular loop from 5 to 0. And let's run it. So when I run the code, what happens is it displays the current thread by saying current thread name is thread main comma 5 comma main comma 5 comma main. Okay, 5 is the priority of the thread, main is a group thread. Your thread which is running is also the main. Okay, so group thread will always be the main. The name of the thread running is main and the priority by default is 5. The priority of the thread is 5. Can we reduce the priority? Yes. Can we change the priority? Yes. But normally we shouldn't do it. Let the system handle it according to the resources. Point number 2. T.setName is my thread. That means the thread which is running, now that thread which is main in the first case is being changed to my thread. So my thread name is changed to my thread. What is the priority of the thread? It is 5. Normally we do not play with the priority. We do not take the thread priority into consideration for optimizing the code. No, optimization has to be done only and only through data structure. That's it. And what is this main? The main is nothing but the group. So on the left hand side, the rightmost parameter is a group. That group can spawn multiple threads and I haven't started any other thread, but my current thread name is changed to my thread. And then what happens? It displays 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. There is a delay of 1 second. If you look at the output screen, there is a delay of 1 second. Is it clear to you? If you have any doubts, kindly type it in the chat window. The priority of the threads. Your program may have thousands of threads running. Okay. So what should be the priority of the thread? It is 5. No, we do not interrupt the thread. It is when your project is running and multiple threads are running, and in case the thread gets interrupted by some activity of the other thread, that time it will give me the main thread interrupted. Otherwise, my thread signature says that it is going to throw an interrupted exception, hence I have to write it. These are the threads started by the Java. These are the threads. Every time you run your program, a Java thread runs. Okay, and that's what we are capturing. We have never started a thread. Okay, till now, whichever programs you are running, the thread was running. You never realized it. Now also my program has got only and only one thread started by the operating system. Okay, and what I had done, I displayed that thread. I changed the name of the thread, and then I'm displaying 5 to 0, 5 to 1 rather, and I'm making it sleep for 1000 seconds. But that 1000 thread dot sleep, if you look at the documentation, gives me interrupted exception. So it is an indication to you that you should write the code in the try catch. That's why I wrote the code in the try catch. Interruption means you cannot interrupt it. Only the different threads which when they are running, it might interrupt them. Kindly note, it's a single threaded program. We haven't started multiple thread. My first program was just illustrating how to capture the thread name and how to have a thread.sleep in a function. The first line of code, line number 3 and 4, what it is doing is it is going to get the current reference to the thread by saying thread t is equal to thread.current thread. And when I run the code, this particular current thread plus t should give me this particular line, which is current thread main comma phi comma main. The last parameter main is a group thread which can start multiple thread. In my case, it is only one thread phi, and phi is the priority of the thread. Should we change the priority? No. Why? For a very simple reason. Do not change the priority for optimizing the code, because it is just a request to the compiler. It is just a request. Kindly change the priority. It may ignore your request. It may ignore your request. It is not a direction that you should change the priority. Depending upon the resources, it is going to make a call. So thread.priority is never considered as an answer for any optimization code. No. Point number 2. T.setName was changing the name of the thread. So if you look at the second output line, after the name change, it says thread, my thread, comma phi, comma main. Okay. So what it has done is it has changed the name of the thread to my name. Sorry, my thread. And then I simply display the content from phi to 1, and I'm putting a thread.sleep. The thread.sleep is 1 second. Okay. So 1 second, 1000 millisecond. Now let's do one thing. Let's comment out this try. Let's comment out this particular catch. So catch is commented, try is commented. Okay, what we have is only a for loop. Only a for loop. This is the end of the main, this is the end of the program. And run it. Okay, so kindly see, when I say thread.sleep 1000, what happens? It gives me an error. Unreported exception, interrupted exception. Your program is not handling interrupted exception. It must be caught or declared to be thrown. It must be caught or declared to be thrown. So analyze this statement. Must be caught. So when I say must be caught, that means you need to have a try catch block. You need to have a try catch block. I hope this clears your doubt about why thread.sleep didn't give an error. How it is going to give an error? It is when my project is running, there may be 500, 600 threads. At that time, if the thread gets interrupted because of any reason, that time it is going to show me main thread interrupted. Otherwise, no. I hope this particular removal of the try catch block has clarified the concept of a thread.sleep. Again, I'm emphasizing we haven't created a thread. We simply have captured the thread name. And the second concept was use a thread.sleep to make a thread, that current thread which is running, sleep for 1 second in the for loop. That's it. So two concepts we learned in this particular program. One was how to capture the reference to the thread, how to change the name of the thread, and how to basically have a thread.sleep in a function. Is it clear to you? Maniruddh, there is no error. It is not a thread interrupted. It is not a thread interrupted. Kindly, it's an error. It's an error. And that error is reporting for line number 13 saying that thread.sleep is not being handled. I think you're not getting the concept. My concept is that this particular try catch mechanism, if it is not written, then thread.sleep is going to give me an error. It is not going to give me an exception. It is going to give me an error. That's what it is showing you on the screen. Compilation failed. Kindly ask the doubts. Thread.sleep means sleep during the execution of the for loop. There is a thread.sleep in the for loop. So what will happen is every time you go from 5 to 4, sleep for 1 second, 4 to 3, sleep for 1 second, and so on. Interrupted will never be interrupted. See, you're catching what I'm trying to tell you is, imagine your project has got around 400, 600 threads and you are using a thread.sleep. So it is compulsory to write a catch interrupted exception. During the course of running the project, you may never face that interrupted exception. Or if one thread interacts with another and it is going to interrupt it, then only you are going to get an interrupted exception. Otherwise, you're not going to get it. But the designers have written the code in such a way that in case there is an exception, it should be caught. So we are catching that particular exception. The working of the thread.sleep is sleep for 1 second during the execution of the loop. If I change this to 500, then the loop will be a little bit faster. No, cache block will not be executed. Wait. Cache block is executed only if the thread is interrupted. Cache block is executed only and only if the thread block is, if the cache block, if the sleep is interrupted, then only you will get a interrupted exception. Otherwise, no. Okay, let's go for the next example. Is my screen visible to you? Now pay attention. I will go very, very slow with this example because this is an example in which two threads will be running. Two threads will be running. Okay. there is a class called as new thread, which is extending a thread. So point number one, in case you want a part of the code to be executed by the thread, you should say extends thread. That means this particular class will be executed by this particular thread. Okay. Now let's ignore this. I won't explain this for a moment. Let's ignore this. There is another class called as extend thread. That means there are two classes. One is new thread, another is extend thread. In which there is a main, function, in which I am simply saying new thread, new thread. That means I am creating an anonymous object and I am simply saying new thread. So when I say new thread, what is happening? The control is going to come over here to this particular constructor, That means this is running as a separate thread because of this particular line, because it is going to say new thread. So it is going to run it as a separate thread. And this particular try catch belonging to this particular class is going to run as a separate thread, run it as a separate thread. Clear? Understood? Let me draw the diagram for you. There is a class A. There is a class B. This says extends thread. Okay. For the time being, let's remove this. In this class A, I am saying B obj equal to new B. Okay. And we have seen this. There is a class A in which I have got a main function. In the main function, I have this particular line. B obj is equal to new B. Now what happened was, your original thread main was started. Okay. This main then executed whatever code was written over here. Because I said B obj is equal to new B, there could be constructor, there could be function, and number of things could be there. So what happened? Main executed, it executed the code in the class B. Once this execution is over, it came back to class A. And then finally the program got terminated. Okay. So this was a single thread. Now since Java provides a thread support, what we did was, we wrote something like extends thread. Only writing extend thread won't work. There is some mechanism for executing it. Now what happened was, I said B obj is equal to new B. So main thread was there. And here we have certain code. There is something called as a start method. There is something called as a run method. These are responsible for starting a thread. So now what happened was, main started another thread. Okay, main started another thread. So let's assume that this is thread 2, which is running. And what happened was, and immediately it came over here and my original thread was running, which is thread 1. This thread 1 has a try catch and this has got a try catch. So now how many threads are running? 2 threads are running, thread 2 and thread 1. So if you want that this code should be executed by a separate thread, point number 1, what we should have? We should have an extends thread. Point number 2, what it should have? It automatically makes a call to the start, and start makes call to the run method. So these are the 3 things we need: extends, start, and run. So whatever code you want can be placed in the run method. Start will automatically make a call to it, and this particular code will be running as a separate thread. So these 3 things have to be there to start a separate thread. 1, extends thread. 2nd, start. 3rd is run. Is the diagram clear to you? If you have any doubts, kindly raise it. Scenario 1. There is a class A. There is a main. There is a class B. It has got a constructor. Okay. And it has got the various functions. In the main, what I do, I create an object of the class B. Thread starts from here. Okay. The same thread comes over here. Execute this particular code. Execution is done. It goes back over here. On remaining statement of the A will be executed. Single threaded application. There is a class A. There is a main. We are creating an object. There is a class B which says extends thread. So when I say extend thread, it gives me two methods. One is start, another is run. So now my main thread started. Okay. It came over here, but it saw that it has got extend thread, it has got a start method, it has got a run method. So this started running as a separate thread. That means this basically started another thread. Main made a call to another thread. Now this thread, as well as there is something called as a try, there is something called as a catch over here. So my main thread is running, as well as this thread is running. As well as this thread is running. That means there is a separate thread over here because of start, run and extend thread. And as soon as I made a call to it, it continued executing this particular code. So this thread is running as a separate one. This is running as a separate thread. Clear? Because we have said extend thread, start and run. We haven't seen the code, but I am telling you the overall mechanism of how the multi-threaded application are executed. Is it clear? Kindly note, we haven't seen the code in the class B. I'm just telling you the mechanism. The difference between single threaded application and the multiple threaded application and what is required. To create a multi-threaded application, A, extend thread, B, start, 3, run. Now let's keep the diagram as it is and come back to this diagram after explaining the code. Okay. Now, this was the first example. Okay. So this was the first example. Then this is the next example. So let's start now. Main. That means now this has started as a thread. This is started as the thread. Okay, let's call it as thread 1 or main thread. Okay. Now till now a single thread is there. Thread means a program under execution. Program under execution is called a process, and when a part of the code is executed by another thread, it is called the process of execution. Thread means the code is executed by a separate thread. Object is not independent. Code is executed by the separate thread, not by the same thread. Whenever a code is running, the process is running. Within the process, a single thread is created that is handling the single program. Instead of that, what we have done, we have said part of the program should be handled by a separate thread. So when I say new thread, okay, what has happened? Main thread is still running. When I say new thread, control comes over here. Control comes over here. It sees that there is an extend thread. Okay. Till now, the second thread is not created. Till now, the second thread is not created. Okay. Now, what happens by this particular line, extend threads? Let's see. In the constructor, these lines are responsible for creating a thread. Now, super demo thread. What happened by using a super? It went into this particular thread class, okay, and it created a second thread. The name of the thread is demo thread. The name of the thread is demo thread. Okay, so I display that particular thread by saying child thread this. So you may ask, what is this? We came over here because of this particular line, new thread, came over here in the constructor. We gave the super command, super went into this particular class thread, gave the name of the thread as demo thread. We'll start a thread. Am I audible to you all? Am I audible? Okay. Okay. So quickly, in case you have missed out my explanation. Started with the main thread, new thread came over here. This particular thread is extending a thread. Second thread created. Okay, second thread displayed. Not yet started. Not yet started. This particular line is going to start the second thread. Now what has happened? Your and main thread I have started. Okay. Now this start will automatically make a call to the run method. Okay, this start is going to make a call to the run method. Am I audible now? I'm not muted. That's what I checked. Okay. So this start is going to make a call to the run. So a demo thread is running and it won't wait for the thread to complete. No. And this main thread is also executing. In this main thread, what I have? 520 thread.sleep 1000. And here what I have? If I is equal to 5, I greater than 0, I minus minus. Let's also make the threads dot sleep as 1000. So what has happened? Both the threads have started. This is a demo thread and this is the main thread. This is the main thread. Clear? So let me go back to my diagram. Let me go back to my diagram and now let me put out the points. Class A is executed by which thread? By the main thread. Okay. It has got a try block. It has got a catch block. It has got a thread.sleep. The name of the thread is main. Here somewhere in the main, I'm saying b obj equal to new b. There is a class b which extends thread. It has got a constructor. In this constructor, what I do? I create a thread. I first of all give the name. Okay. First of all, I give the name. If you look at the code over here, if you look at the code, I give the name to it. Okay. And I display the status of it. I display the status by saying SOP this. Till now, what is happening? Main thread is working. So when this line was called, control came over here, this was executed. Okay, thread has not started, thread is only created. Okay, that thread was demo thread. The thread was demo thread. It is only created. As soon as I make a call to the start, it automatically makes a call to the run method. And this is the place where your logic should be there. And in this, what I have a try catch, the same code which is running over here. Okay. As soon as I make a call to the start, my second thread is running now. So this thread is also running, my main thread is also running. So this is my main thread running, and this is my demo thread running. Okay. So in short, to create a thread, I will need this, and this is just to confirm that the thread is created. This chap is responsible for starting a thread available in this particular class. So I say start and I say run. Okay. This particular start will create a thread, and whatever logic you have, kindly write it over here. So this is running as a separate thread. You may ask a question, what will be the output? I do not know. I cannot predict, because it is the operating system which is going to control the output. Clear? So what is happening in this case is my main thread is also running, my demo thread is also running. My main thread is also running, demo thread is running. Of course, this is running for a very short time, that is 5 to 1, and this is also running 5 to 1. But what you learned in this program was how we can create a thread, how we can start a new thread by using start and run. So point number 1, to create a thread, kindly have a class extend this thread. To display the status, use super. To initialize the thread, to display the content, display SOP this, name of the thread, and start will start that particular thread. The start is going to make a call to the run method. Here this is running, as well as here this is running simultaneously. Is it clear? So let me take you back to the code window, and let's try to run this code. And let's this is not about the output. This is that these threads are starting independently. Okay, these threads are starting independently. So I don't know what will be the output. Oh. So what has happened in this case is, if you look at the output, the name of the child thread is demo thread. Why you got this? Because of this line. This was only changing the name. It was not displaying it. The display is because of this child thread, and it gave the name of the thread as demo thread. Okay. Then we made a call to the start. Start made a call to the run, and simultaneously this particular loop was also executing. Main thread, child thread, main thread, child thread. main thread, child thread, and at some point of time the child will also die, the main will also die. The child will also die and the main will also die. So this particular program illustrated how to have a class extending a thread. So can I have multiple classes started by a separate thread? Yes, you could have a class A, class B, class C started by a separate thread, and in the main you could say new A, new B, new C, and everything could be started by a separate class. Sorry, by the separate thread. See, two threads are running, my main thread and the child thread. Let me copy it step by step, okay? This is the first class. I'm copying it again for you. This is the first class and this is the main thread. Okay, take your time, execute it, then I'll tell you what you're supposed to do. Kindly pay attention. What happens is whenever you are developing a web application, those particular different parts of the different parts of the screen can be handled by different threads. These are the design issues handled by the TL, team leader, and the project leader, depending upon the complexity of the project and depending upon the project resources being allocated for that particular program. Kindly note, thread is not used for optimization. Thread is used for executing the different parts of the code. Now, if you have completed, you are supposed to do these three things over here. So kindly complete it. I need to have 4 threads running, main thread as well as a thread for ABC. The question was, have a look at this particular diagram. In the class main, there is, you have to create objects for 3 classes A, B and C. So this my class A, B and C are going to have a constructor similar to what I had taught you. And they are all going to have a try catch mechanism. With the sleep, decrease it to 500 millisecond. With the sleep, decrease it to 500 millisecond. So your program should effectively have 4 thread running, main as well as a thread for A, B and C. Okay, let me share the screen again. Is it visible? Is it done? So what I was asking you was something like this. let's take this. Okay, so what I told you, make this class as A. Let's have the constructor as A. Okay, let's give the name as A. Change the sleep to 500. Okay, make a copy of it. So this is one of the run of it. What has happened? Child thread A, child thread B. Okay, child thread A, child thread B, and then what I got? I got a child thread 5. Then after that, this particular thread started, C started. So if you look at it, we have just started the multiple threads and they are working. So child thread 1 started, child thread B started. At that time, what happened? The child thread was executed. Okay, then we got a child thread C, then the child thread 5 we got, then the main thread started, and so on. Then the different child thread was starting, then the child thread ended, and then somewhere over here the main thread ended. Run it again and you will have a different output. Let's change the time now to 500 so that program will execute fast because it is waiting for 5 seconds. Clear? So what this program accomplished? This program accomplished how to create a multiple thread. In this program, we created 4 threads, one for the main and one for the ABC. Is it clear to you? If you have any doubts, kindly paste in the chat window. Any doubts? Will the main thread continue after start? Start has got nothing to do with the main thread. Start is going to be only there for the child. So if you look at this particular code, this start makes a call to the run. That's the only job. Okay, this start makes a call to the run and it is running as a separate thread. It has got nothing to do with this particular main thread. Output is unpredictable. Output is unpredictable, but because what you have done, you have just started this 4 threads. That's it. And it is the operating system which will be using something called as a round robin. Round robin means each and every thread will be given, let's assume 100 or 1000 of a second. Then it will switch to second thread, third thread. Yes or no? So whichever thread is going to come first, that is going to be executed. Hence, when you run it different times, you may get a different output. That's why we never ask the code for predict the output in the threads. But what is important is you should know the mechanism of creating the different threads. See, there is something called as a queue. In that queue, whichever thread comes first, that will be executed. Yes. Is it possible that main thread can die first? Yes. Is it possible that the child thread can die first? Yes. Is there some mechanism where the main could be ended at the end? Yes. We'll be learning that. But never think the thread as a predict the output kind of a thing. No. Last concept for today and then we'll stop. Okay, pay attention. So we have seen how to create a thread by saying extends thread. Okay, the second is using implement runnable interface. And we normally use this kind of a mechanism. So we have seen how to execute a thread by extending a thread. But normally what happens, if we want to make a part of the code to be executed by a separate thread, we use something called as a implement runnable. So what does the runnable have? The runnable has got only one method, and that method is run method. Okay. So what is the idea of using the runnable interface? There is a class A. It has got a main function. So obviously this is going to be my main thread. Okay. There is a class B. There is a class B. Okay. It is going to have a constructor. It is going to have a constructor. But this particular class is going to implement runnable interface. Okay. This has got a constructor. In this class, I could say new B. So when I say new B, what happens is it goes over here to this particular class, sees that there is an implements runnable, point number one. Then there is a constructor over here. So what you're supposed to do, you're supposed to create a thread. And once a thread is created, make a call to the start method. Once start method is created, it will start executing a thread. And we know that start method automatically makes a call to the run method. Start method makes a call to the run method. Okay. So first implements runnable. In the constructor, you create a thread, make a call to the start method. Start method will then make a call to the run method. This is step 3. This is step 2. Is it clear? So implements runnable is much more simpler because you have to just implement a run method. Point number one, constructor, create a thread. Am I audible to you now? And have you got both the codes? The one which implements runnable and another one as a main. Try running it. Try running it. Kindly run the code. Point number one, pay attention. I'm not using extends thread. In the previous example, if you look over here, I extended a thread. So in this case, I'm already getting a thread. I'm already getting a thread. So I simply have to say super demo thread. That's it. Because I was getting a thread mechanism from this thread class. If you look over here in this runnable, I'm not getting any thread mechanism. I'm simply getting a run method. So what I have to do, I have to create an object of a thread class by saying t is equal to new thread this, that means get a reference of this and give it a name as a demo thread and then kindly display it. And then for this particular thread, you make a call to the start. And start will obviously make a call to the run method of the runnable, which has been overridden over here. Is it clear? So runnable doesn't give me any thread. Runnable will not give me anything. It is only going to give me run method. That's it. So it becomes our responsibility to create a thread, give the name, and then make a call to the start by saying t dot start. If you look at the previous example, there was not t dot start. It was only start because I got everything from the thread. If you look over here, there was only start. Why? We got it from the thread. But in this case, we have to create it and make a call to the start. Is it clear? The class name implements runnable. The first step, create a thread. Declare a thread and create a thread. Why this thread has been displayed over here? Why this thread has been created? Because if you want to reference it later, you could reference it. Otherwise, if I say thread t over here, then that will be available only in the constructor. That's why I declared a reference outside. In the constructor, create a thread, display the thread, and make a call to the start. Start makes a call to the run. The remaining part of the program is same. Runnable doesn't give me a thread. That's why you have to create a thread, display it, and make a call to the start. Any doubt? In case you want to display the thread in any other function, then how you can do it? You cannot do it if I create thread t inside the constructor. That's why you have to declare thread t outside. Of course, outside the class it won't be visible, but inside the class in a different function, yes. So I hope today I was in a position to explain to you, there is something called as a single threaded application and there is something called as a multi-threaded application. In the first program, we learned how to capture the thread reference and how to change the name of the thread. In the second example, we learned how we could use extend thread to create a multiple threads. We learned the concept of something called as a start and the run method. Start makes a call to the run method. Automatically, start makes a call to the run method. You do not make a call to the run method. You make a call to the start makes a call to the run. Then we learned the second mechanism of using a runnable interface. Because if the class is extending any other class, then we cannot use a thread. Kindly note, if a class A extends any other class, then you cannot use extends to use a thread. I hope you got it. See, what I'm trying to tell you is something like this. If there is a class A, okay, and it is extending the class B, then I cannot say this class can extend thread. I cannot do this because Java doesn't have the multiple parent class. So the only way to do it is using runnable interface. Using runnable interface. Runnable interface gives me which method? Run method. Only and only run method. Hence, in the runnable interface, you have to create a thread. And point number 2, start the thread. So these were the points we learned today. Okay. Tomorrow we are going to continue with the threads. It will be the end of the session for today. You all can leave.